Good evening to all of you. I hope all of you are safe with a good health. Okay. Uh, so in this webinar, so I'm going to discussing the uh, interview questions, okay, which is related to the core company. So our core company is related for the construction and design and animational view of companies, consulting, estimations. Okay, there are all the various number of the subdomains are running in this field. Okay, so today we discussing about the webinar. Okay, this webinar is sponsored by the Edifice Placement Solutions. So I'm going to for discussing the civil engineering core company specific training. Okay, for the written examinations and discussions for the subject is related to the design of RCC structures and detailing of the reinforcement. This topic is related to the IS 456 codebook 2000 year and IS 13920. Okay, these are the uh, this is the today's we're discussing about this topic. Okay, so initially today we planning, so 6 to 8 it is the duration of the training, sorry, duration of this discussion, and 30 minutes is for the DRC, and another 30 minutes is for the design of steel structure, and another 30 minutes is for the MOS, mechanics of solids, and then last 30 minutes we go to discussing about the structural analysis. Okay, these are all the today's topics we're discussing. So first, initially, we're discussing on the design of RCC structures. Okay, so in based upon the this design of RCC structures, so who is an engineer? That engineer, who is a civil engineer, who is the design engineer, who is the quantity surveyor, who is the quality inspection engineer? So there are the a lot of vacancies are available. So if you can choose for the site execution, then you can know about the basics of the execution principles. What are all the execution principles are available? Then site marking and site execution, material arrangements and labor arrangements, quality inspections. Okay, there are all the roles and responsibilities is high for the execution engineer. You can choose for the design engineer, so that field is having the design knowledges is must for each and every one. Which is related to the design of the footing and the design of column, design of beam, design of the slab. What are all the loads are consideration for that particular building, and what are the load combinations are available, what are the combinations are you should apply in your building. Okay, these are all the important of the design engineer. Then you can move for one of the opportunity that is called as an estimation and quantity surveying. So this is purely depends upon the building valuation. Okay, and you can assign the total number of amount of total amount is spent will be spent for this particular building and this particular period. Okay, so this is the quantity surveying department. Okay, so first of all, I'm giving the who is an engineer, and the great ability of the engineer is compared to many of the other professions is that he is a worker out in the open where all can see them. So he cannot bury his mistakes in the grave like the doctors. Then he cannot, like the architect, cover his figure in the trees. So this is important, and the design engineer's responsibility should include the assuring the structural safety. So you are all the give you only the responsibility of your strength of the building. So that how the design is details, checking, shop drawings. These are the roles, and detailing is the important related, which is related to the design. So requirements, so these are all the good detailing. So should be simple fabrication and placing details. This is important for your detailing sheet, and check the spacing for the crack control, maximum of the spacing, minimum the spacing for concrete places, and check for the splicing requirements and the development length for your beams, and special care for the section for varying depth and the slope slabs, and care of the corner joints, beam, corner of the junction of the columns, openings, etc. So these importance you can refer for this detailing, and this detailing is for the gravitational load that is the different from the lateral loads, especially for the seismic forces. So what is an seismic forces? That is a for as an earthquake load. That earthquake load will occur by the x and z directions. Okay, that is responsible for strength of the building. Okay, you can assign your seismic forces in your building. That load is for entire safe, that is called as a seismic forces. Then you can define the this particular load in your software, and you can apply this assign this particular load in your building. Okay, and before that you know about the seismic zones and seismic soil strength where is located, and what is the imperfection factor. Okay, so these are all important. And so apart from this detailing is above, there are the different detailing requirements for the rehabilitation and strengthening of the damaged structures. So this is also important. So core is for SP16 and IS456 needed for this the OSIS. Okay, then next I'm going to discussing about the objective type questions are from this kind of areas. Okay, so companies are expected from the fresh kind of the students. Students are able to explain the questions from HR, or questions from the company managing director, or questions from the site engineer. Okay, etc. So what is the questions are from the this kind of a design of RCC area. So clear cover should be provided for each and every members. It depends upon the location of the building, it depends upon the capacity of the building, it depends upon the design considerations. First one is for to develop the desired bond strength throughout the perimeter of the steel. What is called as a bond strength for the steel and cement, concrete. Okay, so it is for the to desirable bond strength. It is for the perimeter to the of the steel. So to protect against the corrosion and fire. Okay, and what is minimum cover? First is for 20 mm cover is needed for the your slabs. A slab is for the horizontal member to the direction of exit. Is it only thickness is available? So you can provide for 20 mm of the cover is minimum needed to the your concrete reinforced concrete structures. So this 20 mm will maintain the safe of your reinforcements against the corrosion and fire. And the same 20 mm of the cover is uh, maintain the stable of your bond strength. Okay, that is with respect to the your cement and your steel sections. And there are for the beam, you can maintain the 25 mm of the minimum cover is needed for your beam member, and 40 mm cover is needed for your column member. And you can analyze and design for the footing, and you can maintain the 60 mm of the nominal cover in your footing areas. Okay, so these details are in the table number 16 from IS 456. Sometimes the design engineer asking the question from questions to the students. So which one the code book is suitable for covering? Okay, minimum covering and maximum covering. So what is the nominal covering? So these details are from which code book? And so you can explain to the that particular engineer, that particular HR. So these details are from this IS4 pages code book, especially that is in location in table number 16 is for covering. Then next is for spacing the reinforcements. What is called as in spacing the reinforcements? It is needed for any of the member. You can analyze and design for your column and beam and slabs. You can maintain the proper spacing within your reinforcements. Okay, so these are all the horizontal distance between the two parallel main reinforcing bars shall not be less than. Okay, so you can clear check. This is the diameter of the bar. If the bar is our equal diameter, okay, so you can maintain. And the diameter of the larger bar you can maintain, and 5 mm plus nominal size of the aggregates. So you can check all the three conditions shall not be less than. Okay, this is called as a spacing of the reinforcements. Okay, so you can choose for the diameter of the equal diameter, and our maximum diameter of your larger bar you can assign, or 5 mm you can add for your nominal size of the aggregator. So mostly we can use for 20 mm size of the aggregates is needed for the RCC, then you can assign for 25 mm. It is the spacing of the minimum reinforcements. Okay, the maximum spacing as per the design, okay, as per the design is related to the IS 456, particular to the column and particular to the beam and particular to the etc. Then limits for the reinforcements. So what are all the limits you can maintain for the beam? So minimum area of the reinforcement, that is in ASD by BD, it is equal to 0.85 into Fy. Okay, this is from your IS 456 code book, which is related to the bonding strength a Andean standard method. Okay, so maximum of 4% of the BD. What is called as in 4% of BD? Then you can assign, you can analyze and design without this problem. Nominally, you can find the percentage of reinforcement. For example, so one of the client is as per the basics of the site experience. So this is the one of the column. So this is for the B and D. So it is here. So you can assign for 4% of that uh, reinforcement areas in this particular column. Okay, that is an 1600 mm square. Okay, 1606 mm square is for your maximum of the reinforcements. Okay, so then you can choose the 16 mm bar, 20 mm bar, 30 mm bar. It's for the availability of the reinforcement nearby the your source. Then you can put multiplication by d square divided by 4. So you can use 20 mm dia of the rod. You can multiply by the by into d 20 square by 4, and you can assign for number of rods into 4 or number of rods into 6. So this is the maximum of reinforcement. So this is for the assumptions value. Okay, so you can finding the beam. So 4 percentages is for the maximum reinforcement, that is called as 0.4 percentages. Okay, for the compression member, you can assign for the column, you can assign 0.2 percentage of reinforcements. There is the limits. And web reinforcement, you can projection for your beam, that is called as an this compression member you can assign for I section. Okay, this member is considered as a column, and this is for the 0.2 percentage. Okay, this is for the flange portion. You can assign for the total maximum percentage is 4. That 4% is divided into the combustion zone. You can assign 0.2 percentage, and the web portion zone you can assign for 0.1 percentage of the web area. Okay, that is called as an, here it is an web area for the below the slab surfaces. And vertical bars not exceeding the 0.75 times of the diameter of your reinforcements. Okay, these are all the vertical bars. Okay, or 300 mm of the whichever is less, you can assign for 0.75 into 20, or you can assign 300 mm. So this is for the whichever is less, you can choose for your vertical shear reinforcements. And the minimum shear bars you can assign for the classes from the IS456. You can check for the minimum shear bars for the connections, including the beam to column and beam to beam, etc. Then you can assign for the slabs. So minimum of 0.12 percentage for all the flat surfaces of slabs. Okay, this is for the Fe415 and 0.15 percentage for the Fe250. Okay, this is one of the important from interview questions. So I'm going to using for Fe415. What is the percentage for the my reinforcement in the particular slab portions? So you can refer this PPT. So 0.12 percentage for Fe415 steel. Okay, or 0.15 percentage for Fe250 steel. Okay, so this is the important during the interview. Okay, and stirrups, what are all the ties are possible? The minimum size is 8 mm. Okay, so you can assign the each and every building for the ties is minimum for 8 mm nowadays, and can the lateral load to the resistance, and the hooves shall be bent 135 degree of the inclinations towards the end of the surfaces. It is called as an 135 degree of the inclination hook bend. And in columns, the bars are not less than 12 mm. Okay, you can assign more than 12 mm is suitable for your main columns. Okay, client is sorry, HR question is possible. So 8 mm dia I'm going to using this column. How many numbers is needed for one of the self weight withstand by the column? You can explain. 8 mm is not suitable for the column member. So minimum is 12 mm. is from IS 456. Okay, so the spacing of the bars not greater than 300 mm. You can assign for the your main reinforcement spacings. So the maximum you can utilizing the 230 by 230 is for the residential building, 230 by 460 it is for the commercial building, and as per the design specifications you can assign. But minimum is for the 230 mm. Okay, so not more than the spacing is limited for the 300 mm. So it is not suitable. Okay, it is suitable when you design for multi-story building. Your column size is 460 by 460. It is suitable for. So after deducting the this cover, and yeah, after deducting this cover, then your contacting surface area within the reinforcements is 300 mm. It is possible. Okay, otherwise you can maintain the spacing is greater than, should not greater than the 300 mm. Okay. The arrangements of the lateral ties is the classes from the IS 456. So what are all the arrangements are available? You can check this of the code book. Okay. So development length of the bars. So for a concrete grade M20 and a steel strength is Fe415, you can maintain for this kind of um, development length. So this is the uh, serial number to the 1 to 9 for the, which is related to the dia of the bar. So you can assign for the 8 mm dia, okay, in your slab or in your cantilever type of slabs. So the tension zone is you can maintain for the 376 mm square, and the compression zone is for 301 mm square. So this is the contacting length. Okay, what is called as in contacting length? So I'm going to assign this 8 mm rod for my slabs. Okay, this is the, you consider this is the slab. Okay, so here I'm going to assign support is here. So I'm going to assign for cantilever projection is here. So use, you can consider for 8 mm reinforcements, you can connect into the one more length of the main support. So 376 mm is needed for development length. Okay, so there is the normal reinforcement, and here you can assign for this reinforcement. So you can put 376 mm is needed, mm, okay, not mm square. So mm it is needed for in terms of tension zone, in terms of compression zone, you should maintain for the 301 mm length it is needed. Okay, so simply I'm explaining once again. So this is my normal reinforcement. I'm going to add one more reinforcement 8 mm rod to the one end. Okay, so here one end is available, here one end is available. Okay, the enforcement is length is it's enough. So mm is for tension zone, 301 mm it is for the compression zone. So it is called as a compression zone. So available. Okay, you can, it is the interview questions from design engineer or execution department. This question is compulsory that people asking with you during the interviews. Okay, then you can assign for 10 mm. So you can made 470 mm length is needed for the overlapping, and for 376 mm is needed for the compression zone overlapping. So 12 mm rod you can use 564 mm it is needed, 451 it is needed for the compression zone. 16 mm dia you can using in your column, you can maintain for the 752 mm length of each tension member, 602 mm of the length is for the compression member, and 20 mm it is for the 940, 742. 22 mm it is for the 1034 mm, 827 mm for the compression zone. So 25 mm, so 1175 mm, 940 mm it is needed for the this type of a different tension and compression. So 28, 32 respectively for 1316, 1053, 1504, 1203. All the terms are in from the mm. Okay, this is all the approximately uses for the 50 into dia of for tension. It is also possible. Okay, so this is the lab spacing. The labs spacings also from the classes for the 26.2.5.1 from the IS 456. So you can refer what is the spacing of your lapping, and what is the this lapping distance is from here to here how to measure. Okay, this here to here how to measure. Okay, so what is that? This inclination angle. Okay, what is that? This length. Okay, what is that? This inclination. Okay, everything should be in your classes. Sorry, IS 456 26.2.5.1 from IS 456. Okay. So you can assign for this position in your column. So you can rise G plus 2 through G plus 3. So you can compulsory you can make for the lap splicing. Okay, it is needed. So you can arrangements for this reinforcement. It is different height from your slab number 2, and this is same height from slab number 2. This is for the different height from slab number 2. This is for the different height number slab number 2. So these are all not equal. Okay, you can maintain these zigzag wise. So this is here, and I'm going to this is here, this is here, and this is here. Okay, so zigzag wise this lab specimen is arrangements is possible during the quality inspection of your constructions. Okay, you can check and for this one. And next is for lab splicing. So lab splicing should not be used for bar larger than 36 mm. So you can assign for the lab splicing. So 36 mm of the bar, it is not suitable to the cranking. Okay, you can facing difficulties during the constructions. That's only reason for lab splicing is not needed 36 mm of the bars. Then larger than 36 mm bar may be welded. You can assign for the two different of these 36 mm in your main column. You can weld it to that particular main column. The next is for lapping length, including the anchorage value of the hooks in the flexural tension. It is developed for the LD. Okay, LD means developed length of your member or 30 times of your dia, which is greater than. Okay, you can assign it is for the lapping length for anchorages. You can assign for the end zone. Okay, it is related to the flexural tension member. LD L into 16 mm for it is for length of the your member, and D is for the dia of your bar. So you can multiply get one value, or 30 into 20 mm dia, so 600. Whichever is less, it is for the lapping length. Or the lapping length including the anchorage value of hooks, that direct tension is for the 2 times of the developed length, or 30 times, whichever is greater than. Why? What is the difference between the this values of the member? You can assign for the direct tension, you can multiply for 2 LD. You can assign for the flexural tension, you can assign for the LD. Okay, this is the different. So flexural or direct tension, this is the different. Okay, so 2 LD it is for the direct tensions, one number of the LD it is for your flexural tensions. So the straight of the lapping length should not be less than 200 mm. That is for the 15 mm, whichever is greater than. So this one is important for interview questions. Okay, so lap splicing continue. So these are all the lap splicings are considered for the staggered if in the center to center distance of your reinforcement arrangements. So that is not less than 1.3 times of the lapping length. Okay, so you can assign 600 mm. Okay, it is suitable, but you can this is not exceeded for the 1.3 times of consideration length during the staggered reinforcement. Then lapping length for the compression zone, that is equal to the development length compression, but not less than 24 mm dia. Okay. 24 times of the dia of the bar. Okay. So each and every terms it should be differ, and different diameters have to be spliced in the your concrete column or concrete beam. Okay. So do for the detailing. So prepare the drawing properly and accuracy. This is for the important one, and prepare for the bar bending schedule. Okay, if necessary. Okay, this is the important one. Okay, the next is for the indicate the proper cover to the reinforcement. These are the important one. So decide the location of the opening hole. Simply adequate details for the reinforcement surrounding openings. This is important one. For the you can focusing the main for openings. Okay, you can maintain for the adequate details, the support member to the reinforcements surrounding the your extremely load acting value. And commonly available sizes of the reinforcement. the bar spiral shall be used for reinforcements. Okay, so you can assign for available sizes. Okay, you can, what, 23.5 mm needed, it is not suitable in it is this type of a diaphragm is not available, so you can use available size of the reinforcement only for your design considerations. Okay, 8 mm, 10 mm, okay, or 16 mm, 20 mm, okay, 22 mm is available. And for the single structural members of the number, different size of the reinforcement bar should be minimum, and the greater reinforcement bars should be clear the grade. So I'm going to worry before in your particular detailing drawing to expose it for the future constructions. So you can get identify, or you can consider before the analyze the design, you give your projections or you give add for the facilities to the exposure in your building. So this is the important one. Okay. And the congestions or the reinforcement should be avoided. What is the congestions? How to reduce this type to the beam connections? So you have
மைக்ரோஃபோன் கொஞ்சம்
in
திடீர்னு
your
எக்கோ அடிக்குது, கொஞ்சம் கரெக்ட் பண்ணிக்கிங்க.
that again.
ஹலோ சார், உங்களுடைய மைக்ரோஃபோன் கொஞ்சம் அப்பப்போ கொஞ்சம் ரோபோட்டிக் சவுண்ட் மாதிரி வருது, கொஞ்சம் அதை கரெக்ட் பண்ணிக்கிங்க.
இப்போ கிளியரா இருக்கா?
ஹலோ
இப்போ கிளியரா இருக்கா?
ஹலோ
Karthikeyan,
ஹலோ
it's audible?
சார் கேட்குதுங்களா? எஸ் சார், வாய்ஸ் இஸ் கிளியர். சார் இப்போ சார், எனக்கு கொஞ்சம் பேசும்போது கொஞ்சம் வாய்ஸ் ஆடிபிளாக இல்லை, அது போக சம் சவுண்ட் வருது, அது கொஞ்சம் கரெக்ட் பண்ணிக்கிங்க மைக்ரோஃபோன். ஓகே சார், ஓகே சார், தேங்க்யூ. ஓகே சார், கேட்குதுங்களா? எஸ் சார், வாய்ஸ் இஸ் கிளியர்.
Karthikeyan,
இப்போ ஓகே சார், ப்ளீஸ் கேரி ஆன்.
now you can check my voice quality.
எஸ் சார், இட்ஸ் குட், யூ ப்ளீஸ் கேரி ஆன். சார் பார்த்தேன் சார். ஹலோ ஹலோ, யூடியூப்பில் கொஞ்சம் ஆடிபிளாக இல்லாமல் சார், ஒரே நிமிஷம். ஓகே, நீங்கள் கொஞ்சம் மறுபடியும் இந்த ரிப்பீட் பண்ணுங்கள் சார். கொஞ்சம் ஒரு 2-3 ஸ்லைட்ஸ்லேருந்து போய் பண்ணுங்கள்.
So do's for the column, do's for the beam. So what are the columns? So you can assign for the 4 number of the main reinforcement for rectangle and a square. This is needed. You can use for the circular column minimum of 6 number of bodies.
Sir, பார்த்தா சார். ஹலோ ஹலோ,
do's for the column. Yes.
யூடியூப்பில் கொஞ்சம் ஆடிபிளாக இல்லாமல் சார், ஒரே நிமிஷம்.
And keep outer the dimension of the column is constant. Okay. And so far as possible for reuse that same column. You can assign for this particular column in different way. You can form the same reuses method is available. Okay. You can view the positions.
நீங்கள் கொஞ்சம் மறுபடியும் இந்த ரிப்பீட் பண்ணுங்கள் சார். ஒரு 2-3 ஸ்லைட்ஸ்லேருந்து போய்
Hello.
பண்ணுங்க.
Bars in the same
Hello.
element. Okay, so below the ground level it is called as
சொல்லுங்க.
for the underground so superstructure. You can assign for the
அதான் இப்போ மறுபடியும் இது பண்ணியிருக்கோம். இப்போ கேட்கும் இல்லையே, கேட்குதுங்களே. நான் யூடியூப்பில் நானும் பார்த்துட்டு இருக்கேன். பாருங்கள், யூடியூப்பில் தான் நானும் கேட்டிருக்கேன், ப்ளே பண்ணிட்டு இருக்கேன்.
So whenever provided for the input, they should be staggered and away from the maximum of the source. And not exceed for the 750 mm in the case of the beam without the torsion, and 450 mm it is for the with the torsion. Side facing the reinforcement should be provided. Facings are in the proper arrangement. Okay, this is for the reinforcement. So finally, you can get view for the bar bundle schedule. So the schedule is important for the identification of the structural member. So your arrangements is explaining this is the identification of the member. And the next one is for the position of the each bar in the member. And you can see for the bar marks and the bar diameter of each bar, number of the bar, and shape and the bending dimensions of each bar, length of the all the bars, remarks if any. Okay, what is called as remarks? So you give the projection.
சார், எக்ஸ்கியூஸ் மீ சார். பார்த்தா சார்.
You can assign for the end of.
பார்த்தா சார்.
Yes.
சார் கொஞ்சம் லவுடாக பேசுங்க சார். யூடியூப்பில் லோவாக இருக்காமா வாய்ஸ்? சார், யூடியூப்பில் வாய்ஸ் லோவாக இருக்காமா, கொஞ்சம் லவுடாக பேசுங்க. ஓகே சார்.
Okay. You can check your audio connections also. So your audio connections I think minimum.
இல்லை, ஃபார் மீ இட்ஸ் ஓகே, பட் நோ இந்த வென் இட் இஸ் யூடியூப்பில் போகும்போது கொஞ்சம் இதாக இருக்கும் சார். ஸோ கொஞ்சம் நீங்கள் லவுடாக பேசுனீங்கன்னா கரெக்டாக இருக்கும். மைக்கை வந்து கொஞ்சம் மவுத்துலேருந்து கொஞ்சம் தள்ளி வச்சு பேசுங்க, அப்போ கரெக்டாக இருக்கும். ஓகே சார்.
You give the main remarks about your detailing. So the remarks are if any. So you give for the main column, and this is for the end of the beam. So you give the remarks if you have enlarged this beam. So this is the outermost of the your boundary area.
Sir, excuse me, sir. Pata, sir.
The remarks for the this is the position.
Pata, sir.
This is the.
Sir, கொஞ்சம் லவுடாக பேசுங்க சார். யூடியூப்பில் லோவாக இருக்காமா வாய்ஸ்? சார், யூடியூப்பில் வாய்ஸ் லோவாக இருக்காமா, கொஞ்சம் லவுடாக பேசுங்க.
This is the containment zone. So these are all the remarks. You can for the
ஃபார் மீ இட்ஸ் ஓகே, பட் நோ இந்த வென் இட் இஸ் யூடியூப்பில் போகும்போது கொஞ்சம் இதாக இருக்கும் சார். ஸோ கொஞ்சம் நீங்கள் லவுடாக பேசுனீங்கன்னா கரெக்டாக இருக்கும். மைக்கை வந்து கொஞ்சம் மவுத்துலேருந்து கொஞ்சம் தள்ளி வச்சு பேசுங்க, அப்போ கரெக்டாக இருக்கும்.
and the zone 3 that is the one.
ஹலோ.